Well, I think congratulations are in order. We have a new baby on the bench. Isn't it cute? Oh, good little baby. And I think it's a boy because it has a blue dial face. Oh. All right, let's check it out. Okay, let's get your little nappy changed, and when you grow up and eat your capacitors, you'll be a big 2500 one day. So what we have here is a little baby Marantz model 2015. And the 2015 is a pretty rare model. Believe it or not, the 2215 came out before the 2015, and this one was only made for about 1 year or so, kind of over the course of 2 years. And we're going to look at some history of this, kind of compare it to the different models, because there was a 2215, a 2015, a 2215B, and a 2215BL. Believe it or not, they're very, very similar. The 2015 and the 2215 especially are very similar. Now, there were probably 4 or 5 different variants of the 2015. Even though it was only made for a year, they really came out with a lot of different models of it. So this is kind of the later model. Well, it's kind of the middle of the run model. The earliest ones only had one tape input. And if you know, and this is called a 4-button unit. So there were some with 4 buttons and then later ones with 5 buttons. So the first generation only had the single tape monitor. Later on, they added a muting button here, I think, and the tape 2. So that was one of the changes. Then they went to a 5-button where they actually had a variant that had Dolby FM, and I think they had another one that had some other kind of high-pass filter or something. So depending on what generation of it is, even though it was all only made over like a 2-year period, you could have any of one of those models. So these are all very rare. The 2215s are actually a lot more common. The 2215 was made over a longer period of time, and they're actually older than this. So it's kind of strange. They also made a 2010, which is a 10 watt per channel version, and I believe it was an earlier model than this. And then the 2215B and the 2215BL. The BL is just has a long wave FM or long wave AM, I think. So it has AM broadcast, FM, and long wave or something like that. That's what the L is in BL. And also the B series is the latest model, 2215B, and they had they kind of cut back on the build quality a little bit. They're a little bit lighter weight and so forth, but of all of them out there, these are probably the more rare ones. And sound wise, I would have to say that the 2015 and the 2215 are going to sound almost identical, because when you see the schematics, you'll see there's really no difference. This is actually an improvement over the 2215. They did a couple things to make it a little more stable, especially with the bias circuit. Just some minor tweaks, and these are known for their sound. As a matter of fact, they're revered among some folks who use high efficiency speakers, because they claim that these actually, in some cases, will have a better sound, a warmer sound, than some of the other high-end and higher power models of the Marantz. So these are pretty sought after from what I understand. So I'm pretty excited to check this thing out. I don't know if it works or doesn't work. I don't know what kind of condition it's in. We're going to find out, and we're going to see if we can get this thing looking and working like new. Another thing I think is the 22 series are a little bit larger. This was kind of a compact model, so that's why a lot of times these are called the baby Marantz. That's kind of why I poked a little fun at it. So I went ahead and printed out the just the amplifier section of each of these models. And because I know there's a lot of debate that goes on some of the forums about which one sounds better. And some people say, you know, that one sounds way better than the other. The only thing that I could see that would be different is if one of them had a slightly bigger power supply than the others. But circuitry-wise, these should really sound about the same. They all have this, at least the non-B series, like the 2015 and 2215, they all have these 2SD315 outputs. And you can see this is all NPN output. And it's a single rail power supply, which means it's going to be a output capacitor coupled. So you can see this capacitor here and your little snubber network. Those go straight out to your speaker terminals. And if you follow it back, it goes right to the junction point of the two outputs. So what that means is the center point, the midpoint of the two transistors is going to be sitting at about half of the rail voltage, which is why you need this capacitor to isolate that offset voltage from the speaker. The good news is if one of these shorts out, that capacitor will protect your speaker from any DC offset. So there's no need to have any speaker protect relays or anything with this kind of design. So there's two adjustments in these. One is your actual bias, and take a good look at it right now. It's really pretty simple. You have a diode and you have a pot, a 470 ohm potentiometer that sets your bias. If this opens up, you could be in a world of hurt, or if something goes wrong, because this thing could go all the way to the rail. Now that won't hurt the speaker, but of course it could cause some problems with the transistors. In addition, this is but isn't a offset. It's actually a midpoint adjust is what we call this. And what we want to do is you can adjust these two different ways. The quick way is to put a meter on there and measure your DC voltage, whatever it may be. Like if it's 50 volts, you would set that midpoint, you put your meter right here and set it for half of that, so like 25 volts, and it'll get you in the ballpark. But the correct way to do this is to run like a 1 kilohertz signal into the amplifier, drive it really hard till it's ready to go into clipping, and just as it starts to clip, you adjust this until the top and bottom clipping are symmetrical. We're going to do that. I'll go over that whole process in this. This is going to be kind of a solder and chat video, just fun. We're just going to have fun because it's such a simple little thing. We'll talk as we go along and maybe go over some basics for some of you who are really just getting into this thing. It might be a good video for you if you can put up with all my chatter, because it's a solder and chat. So some of you are going to like that, some of you aren't. All right, so like I said, the original one was the 2215, and it was produced from 1971 to 73. So that's only a 3-year span there. And then they came out with the 2015, which is this one, and it was made just from 74 to 75. So you could see that's pretty, not very long these were made. And that's why, with so many different variants, that's why these things are so rare. And then the 2215B series was made for quite a while. It actually overlapped with the last year of the 2215, all the way spanned across the 2015. So the 2015 and the 2215B were being manufactured at the same time. And then the 2215B was from 1973 to 77, with the variant of the BL, meaning it has the long wave band on the tuner as well. And you can see they changed a few things on it. You still have your bias, but you don't have your midpoint adjustment anymore. They put these little light bulbs in there as kind of like a current limiting. And what these will do is as you draw current, these will change their resistance because it's a filament. And you can see that's going right into the output there of one side. So they just kind of cut everything down as far as they possibly could on the B series, although they still sound pretty good from what I understand. And they probably went to a different transistor too. I've not looked inside of one of these, but I would imagine these two SDs here, what is this, H711? It's cut off up here, but these are probably TO220, like the little square transistors. And you're going to see the one that we're going to work on has the TO66, or the little oval-shaped metal transistors. Both of these models will have those same transistors. So it's very simple. You don't even have a differential input pair. You come straight in to your input transistor and go into your voltage amplification, and then here's your drivers here and your output, and this is your overcurrent limit. I believe that's what this is. We'll have to look into that a little more, but I believe that's what that is. And yeah, I think that's it. And right there's your bias circuit. And notice on the 2215, they just have that pot there by itself. But when we went to the 2015, they put this little thermistor right across, or varistor, right across the pot. So what's going to happen is that's going to help stabilize things as the transistors heat up and voltages change. This will vary a little bit to stabilize the thermal tracking a little better. But also, if this pot opens up here, current will still flow through this, and it'll keep these things from driving all the way to the rails. So it's just a better bias circuit all around. So I'm kind of interested in taking this apart now and seeing what kind of condition this is in. It's not bad on the outside. It's a little bit dirty, but it's not corroded or rusted. Faceplate is going to clean up very well. The tuning's kind of rough, but it does drift a little bit. And you're not seeing a darn thing. Yeah. So let's get it apart. So I'll leave that little scene of me taking the screws out in the video, because I heard a comment. I was watching a Shango 066 video, and he expressed how much he absolutely loves watching people take the screws out of their stereos and radios when they take them apart. So that one's for you, Shango. So this thing is pretty crusty. Just has a lot of dust. Nothing that we can't clean up. Okay, we're plugged in. I have a 100-watt bulb in right now. Okay, we got a light. That looks good. Let's see if we have any voltages here. Of course, there's no need to measure the speaker terminals for DC offset, because again, you have these capacitors in there. But what I will do is I will look at the midpoint, and if we get the schematic out, we can see that that will be, well, if I look at the collector of one side, I should have 50 volts. And then on the low side, I should have 23 volts, 23.5 on the other collector. So that's all we have to do is measure the two collectors of the transistors, which we can get those from back here. And what we'll do is we'll put our meter where we can see it and where it doesn't have a bunch of glare on it. And let me get, ground is ground all around, I'm pretty sure. There's your 50 there. Of course, you're going to have it here. 50 there. Let's reach down in here and try not to short things. 21. So that's not too far. It's supposed to be 23. And this side, 22.4. So it's off a little bit on the midpoint, but again, that might be normal, because the final adjustment really isn't about what that midpoint voltage is, but really it's about symmetrical clipping. But this tells me that the transistors are turned on and they're biased, and that means that this whole thing works. Okay, we have some speakers. The unit is on, and nothing. Absolutely nothing. Okay, so first thing I notice is I do have an antenna connected, and of course the bar antenna for the AM is there, and I have no sound out of either one of these. And we have a lot of stuck switches as well, and I have no sound. So yeah, look at that. I mean, it's totally dead. So that tells me that we have probably the low voltage power supply. So the main rail supply obviously was there in the outputs, but there's probably a second power supply, I don't know, we'll have to look at the schematics, that might be, you know, that feeds the tuner and the preamp and all that, and it might not be functioning. So we're going to have to check that. So let's turn this off for the moment. All right, so I do not have the entire schematic down here. Unfortunately, I'll have to print that out. But let's turn this back on. And let's see if we, I mean, we have our lights, but that's usually an AC thing. Yeah, those run on like 8 volts AC. But the tuner and nothing else is working. So if we measure voltages here, let's check here and see what we get. So there's 42 volts there. Nothing. Should be another one of these that's 42. And there it is, 42. So this is only a single power supply bridge rectifier. So 42 volts. And we do have our 42 volts. And then your big power supply right here for your DC rails, that's your 50 volts, and you can see we have that. So we have our 42 and we have our 52. There you go. So there's voltage getting there. So what else could it be? Well, could be something to do with the phono jack. It could be something to do with the speaker switch. Any number of things. I know the transistors must be good because, and there's your midpoint there, which is the same as when I was looking at the other collector. And the midpoint for this side is right here. So these transistors are biased. They're turned on. They're functioning. I don't feel any heat or anything like that. So really, if I go to the input of this, which, let's see what we got. The input would be J601. See that? J601 and 604. So if we look on here, we should find J601 and 604. And those are back in here. There's 604. And I don't know if you hear that, but let me hold the microphone. Hear that? And then J602, did I say? I'm sorry, 601 and 604. So 601 is right here. Amplifier is working. So what that's telling me is that we're getting power to the amplifier, we're getting power to the preamp and everything, obviously, but we're not getting any signal passing through. So that tells me it's something with the switching or something. So we're going to have to go underneath and take a look. Okay, now that we have it open under here, let's go to auxiliary input. Let's turn the volume up a little bit. And the auxiliary jacks are back here. Let's touch those. All right, So the amplifier and the preamp both work, and the volume control works. So we're just not getting anything from the tuner. How about the phono? I can hear it humming already. I can hear the phono stage humming. Okay, so I got one channel there, and I got the other channel there. Perfect. Man, that thing's got a lot of bass. I don't even have the loudness switch in or anything. So it seems like the only issue we have is that the tuner is dead. So why aren't we getting tuner? No tuna. Way, if you're going to use your finger as a troubleshooter, number one, this should go without saying, don't poke your fingers around places where there's dangerous voltages. If you don't know what you're doing, don't do that. Once you get a little more familiar with this, you learn the different parts of the amp that are safe and the ones that aren't. Second of all, this is a really good test to just quickly see, without using any kind of tools or anything, what parts of the amp are functional and what parts aren't. So we've just determined that the phono stage works, the preamp works, the volume control works, and the power amplifier works. So, and the speaker switch is working because we have that pushed in and it's driving the speakers. So really, we're narrowed down to only one thing, and that is the entire tuner module itself. So that usually, FM and AM are kind of their own separate things for the most part. They do share a few common things, but typically, what's the rule? Thou shalt check thy power supplies. And that is the golden rule of troubleshooting. Always check your power supplies first. So let me print out the schematic so I can have something to look at, and we can check a couple of voltages around here and see what we're getting. Okay, baby receiver, baby schematic. So here's our power supply. It's a very simple one. There is one regulated line here. It appears to be a 35 volt power supply. And there's also a 14 volt. Okay, so there's a couple of them here. So we can check our 14 volts and our 36 volts. And we should be able to go back to this power supply board, which is right here. And there should be a transistor on there, and that appears to be this one right here. I don't know if you can see it. See that? And that is a really small transistor for a voltage regulator. But that's what it is. And let's see, J802 is your 35 volts, and J801 is your 14 volts. I wonder if one of those is gone. So let's see if we can find out. So J801 and 802, is that what I said? So oh, of course they're clear in the back where you can't get to them. So let's look at the emitter of the transistor, and that's marked on the board. So let's go from here to here. I got 35 volts. See that? So the 35 volt supply is working. And if I get onto the cathode of H809 diode, there's 808. Where's 809? It's probably buried. There it is. 809. That's going to be it right here. And we have 14 volts. So the power supplies, to my surprise, are both good. That's not too good there. It's strange that there is no sound at all. It's completely dead when you select the tuner. Both AM and FM, which are two different sets of contacts on the selector switch. So that's kind of tells you that it's probably not the selector switch, but being that we have power, I don't know. So let's see what we have over here. Do we have some voltages as I bang the camera? So for instance, let's just start over somewhere in here. H108, the collector. So H108. See if I can find that. There's 111. There's, let's see, H112, 107. These are those dome-topped. That looks like 108 right there. Those are those dome-topped transistors, which is always a scary thing. So let's see what kind of voltage we get. We go on H108. So let's look at the collector. There's 13 volts there. And let's see what's on the emitter. Should be nothing. How about that? In the base, 4.1. But the emitter has nothing. And I can't imagine I'm that lucky that I found the first try the bad transistor. So that's supposed to be, well, yeah, I'm on FM. So that's right where the ratio detector is. I should see my 12 volts on the collector and 4 volts on the emitter. Right there. 12 volts, 4 volts. And that appears to be H108. Kind of hard to see through all the dirt, but that looks like a number 8 under that screw there. Oh, wait, here's H108. My bad. All right, collector is, there's your 13.8 on collector there. Emitter, yet. Absolutely nothing. So none of these are showing anything. So there's got to be a short in here someplace. 5 volts. So I wonder if something, I don't know. How about H106? See, I'm going way back. How about let's go forward a little bit. Let's look at H111 and H110. Wonder if maybe the muting circuit or something is whacking out on us. So let's look at 111 and 110. So there's 111. 111 says we should have not very much on anything. They should be just about 0 volts all the way around. And they are. I could show you the meter, but you can take my word for it. Okay, so that's good. H110 should also be 0 volts all around. And then in parentheses, so what does the parentheses mean? That probably means one is when the tuner's selected and one is when it's not selected. So I got 12 volts on one side, 0.2 on one side, all right, and a couple of millivolts on the other, and that seems to be correct. Wait a second, no, maybe not. So we have some strange voltages here. Okay, so comes out of the ratio detector, because we have FM selected right now, goes around here, goes here, goes all the way across through this little coupling capacitor here, and down into your multiplex stereo chip. And pin 1 should be 2.8 volts. So that's going to be right down there. So let's see if we can get everything in shot here. And pin 1 is right here. 2.8 volts. And when I touch it, I can turn the volume up a little bit. Yep, I'm getting sound. Really quiet sound. I mean, I have to crank the volume way up to get anything that you can hear. But I am getting something. And I am getting 2.8 volts. So I'm wondering if there's a transistor, like a muting circuit or something, that is blanking this out. Okay, so pins 10 and 11 are the right and left channel outputs from the multiplex chip. So if I touch those, number 1, I should see 6.8 volts. And number 2, I should inject some noise that I can hear. Now I have the volume turned way up. So let's go to, there's pin 9, there's pin 10. And I'm getting just, yep. And it's 8.9 volts. So 8, 9, 10. Pin 11, same thing. It's, wait, 9, 10. And pin 10. So 10 gets sound. 11 gets sound. And they both have 8.9, almost 9 volts on them. And strangely enough, these are supposed to have, this one's 9.6. And I don't know the pin out of this thing totally. I don't know which every single pin is, but our outputs, you can hear it in the amplifier when I touch with my finger. But something, this should be 6.8 volts. And it's way high. So I'm wondering if something is causing that to happen. Okay, right at the output of R143, right there. That's the output of the ratio detector. So if I select FM and I go down to this R143 resistor, so I am getting signal. So it seems to me like there's no oscillator action, which is strange because neither the AM or FM are working. So let's enlist the help of an old friend here. I have this hooked up, and what I'm going to do is I'm switched over to AM. I've got this thing warmed up now. It should be warmed up. And I'm going to check right on H113. This is right around your local oscillator for the AM and everything. I should be able to get something, especially if I go to the base or the collector. Let me see what we get there, H113. So 113 is one of these dome transistors right over here. Let's go on to base. There's really nothing there. Let's go on to collector. And we have it. So the oscillator's working. Let's see if we can tune stations with that like that. Go in here.
Don't get suckered into the same old free phone game by big wireless that comes with a lot of fine print, plus. Oh, in other words, you pay more. At the end of the day...
Now, of course, it's real wide right now because it hasn't gone through any of the filtering or the IF stages, so you have a real wide tuning range if it's a real strong station, but it's working. So let's see if we can get it. We should see something coming out at going into the detector right there. So let's check that. L117. Where's that going to be? L117 should be pretty nearby. And that's right here's L117. I should be able to get close to it. Let's get on these. Nothing there. Nothing there. Of course, I wouldn't expect anything out of this one because there's it's detected audio by then. So, am I getting through my IF stage? That's the question. Let's check it out. Okay, so we come out of the oscillator mixer. Hold on, let me give it a pointer here. So here's the oscillator mixer. And it should go in to this transformer right here. And I should get, coming out of here, you can see where I should get an IF transistor here. So I should see something coming up into the base of H104, and I should be able to pick that up somewhere around R117. So let's see if I can find that. And 117 is right here against the tuning gang, so I have to be kind of careful here. Let's see if I can get on there. And it's dead. So I got it here.
Because man is a win worth some.
But I don't have it here. Do I have it on either side? No. So I don't have anything coming out of that transformer. Let's go to H125 diode. That's right here. Is H125. That's the diode. That's a diode coming right out of the oscillator mixer. 122. And let's see what this one is. 125. That's this one. So that's this diode right here. So let's see where I should be. There it is.
Straightforward ad. See if you could save at progressive.com.
So I have it there. So it's going. I have a goes into. Let me get you a little closer. So we have a goes into right here. We don't get a goes out. So let's look at 117. Once again, I'm not getting anything out of 117. Right there. It is dead. So do I have a bad transformer? Is this IF transformer bad? And it is kind of weird that I'm not getting anything out of either side, so I wonder if this transistor is bad. Let's check voltages on H104, because if it's shorted, that would block AM as well as FM from working. Neither one would work. Because you could see it, you have your IF right here. It's using the same IF for FM and AM. And then the AM comes down here and gets detected here. The FM goes through the rest of these stages, your limiter and all that, and it comes out and goes through your ratio detector and gets detected here. So if one of these is bad, that would, or right back here, 104 and 105, if one of those is bad, that would cause it. And 104 is the one that's looking like where we're losing everything. 104 should be a transistor that's right over in this area here. That's 103. There's 104 right there. So I should be able to go onto the base of 104. It is absolutely dead. And if I go to the emitter of 104, it is equally dead. So 104 could possibly be a bad transistor. So let's check voltages on it. See how we're doing this? You just follow the signal. Now it's kind of difficult when you have an oscillator problem like this or an IF problem like this. It can be difficult if you don't have something like a scope or a signal tracer or something like that, because you really have to be able to follow the signal through there. So according to the schematic, I should have 1.5 volts on the base, 6.2 on the collector, and 0.8 on the emitter. I don't know if you can see all that there. So let's start at the base. We want 1.5 volts, is that what I said? So it's going over here. And it's not 1.5, it's 2.1. And if I go to the collector, what's that? 13 volts on the collector. Well, that's not right. It's supposed to be 6.2. And the emitter should be 0.6. And it is absolute zero, so that transistor is not even turning on. I think we got a bad transistor. Okay, I've set the meter to diode mode, and I don't know if we're going to be able to check this or not. We'll see. Some things don't really test that way, but this is an NPN. That means the P, or the positive, will be on the base. So from base to emitter, I should see a voltage drop. And I don't. Look at that. And if I go from base to collector, again, nothing. Touch it together, I have it. It's a dead transistor. We have a bad transistor. Nice. Okay, let's see if we can find out what kind of transistor that is. It is a 2SC536G. Okay, let's look this up. I got my book, 2SC 536. They're showing that as a TO3. That's not right. But of course, 200 milliwatts, so they just have the wrong drawing there. So 40 volt, 100 milliamp, 0.2 watt, universal is the application for it. And they're saying that all of these will replace it. I don't know if I have any of those. Oh, 2SC 945, 2SC 1815. So one of those should work. I have 945s. What I don't know is if I have any real high gain ones. The good news about a 945 and an 1815 is that those are low. Well, the 945, I think, is a low noise transistor. I could be wrong. Okay, so here's what I found. I have some of these KSC 1674s, and I think they're going to work. Collector emitter voltage is 20 volts. It's 250 milliwatt. The collector current is rather small, but I don't think that's going to hurt anything on this application. I don't know. That is, let's see, I got 6.2 on one side. So there's only, there's the maximum that you can have on there is 13 volts, and this is breakdown is 20. This should work. I would say this will work. These aren't going to run at 20 milliamps. They're very low current devices. Alright. And I think I figured out which pin's which here, but you never know. Okay. And is the third Must be this one here. Yep. All right. Get the little pliers. See if we can bend these little leads here. So sometimes the old tools still work pretty well. And yes, I know about the Mr. Carlson Super Duper probe. You all don't have to tell me about that. I know about it. I don't have one, but I'm sure it would work great. So let's check this out here. There we go. See what it says. Hope it says bad component. Ah, ha ha ha. Yes. Okay. And this one's supposed to be emitter base collector. And it is emitter base collector. Okay. So let's put this in there and see if it works. Put this in there. Get her soldered in. See what happens. See if Bob's our uncle, huh? So even the simplest, smallest little pieces of gear can be challenging to fix. This is good. This was a very good troubleshooting video. Of course, we're not done with it. We got a lot more we're going to do here. But definitely, that's at least something. Think it'll work now? Placing your bets? Let's find out. So we'll go over here. Turn the volume down. Turn the unit on. Well, plug it in first, I would suppose, huh? Hey! Let's put the antenna on. Okay, it works. Let's see if I can connect the signal generator real quick and see if I get some kind of output on that. Yep, fixed. So let's see if FM works now. Plug the FM antenna in, and I bet you it will work. Or it will not work. How about that? Still no FM. That's pretty scary, huh? Let's see. Not getting any output. Well, we're going to have to trace that now too, aren't we? Okay. Fortunately, I keep my feathers numbered for just such an emergency. All right, so let's go to the same place. Work our way forward. Maybe its oscillator is bad as well. I don't know. So let's do H102, the collector. Where is H102, you might ask? I don't know. H102, right here. So there's the collector. I don't know if we can see. Turn off that. See if I can get in here without shorting everything out. it's acting the same way. Nothing. Nothing. So I'm not getting anything even on H102, which is right here. Let's try the base of 102. I really don't think I'm going to get anything on that. Let's see. Something going on there, but I think maybe that's a bad transistor also. Let's check some voltages again. 102. It's these dome top transistors. They suck. Whenever you see these little transistors, the little dome top ones, little tiny, they're very bad. They use them in cheap transistor radios a lot. They're not very good quality, and they have a pretty high failure rate. So the base is 2.2 volts, emitter is 12.4, and collector is 1. So let's look at the base. And it's supposed to be, look at that. Base is supposed to be 2.2, 11.9. Oh, good grief. Do we have another shorted transistor? That's pretty cool. We got 2 of them that crapped out. Yeah, that's shorted. That's 0. 13, yeah. Another bad transistor, I think. Let's pull that one. All right, let's try this one and see what it looks like. If it's a turd. It's a resistor. What are the odds? Pretty good, I guess, huh? All right. So that would be emitter base collector. So again, bend the pin forward, the middle pin. Let's see here. Just heating all this up around here. All right. Very good. Snip these a little bit. Well, I don't know. Maybe the FM will work, or maybe there's another one, because these dome transistors are crap. So, wouldn't surprise me. And then we're going to have to make sure we don't have any noise or anything like that. Okay, are these in there good? Yes, they are. Okay. Plug it in, turn it on. Nope. Still no good. AM works. FM does not work. So do we have another bad one? I guess we'll have to find out. So I don't even know if you were seeing what I was doing. All right. So now let's look at the next one in, which is going to be H. Let me see what this one is. H103. 103 has to be good because that's for the AM as well. So I don't think that's bad, but well, maybe it is. Let's look at 103. It's 12.1, 5.8, and 5.2. So 12 point. There's 5.8. 5.2. I bet you this one's 12.1. And it is 12.5. Close enough. So that one is good. I figured it would be. So now going down the line, if 104 was bad, what if 105 is also bad? So let's look at 105. And heaven only knows where it is. Can't tell if this is, that's right there's 105. So 105 should be 6.6. Let's see, 1.8, 1.2, 6.6. So 6.6 on the collector. Nope, that's 7.6. How about the emitter? Is 1.1. That's not too far off. And the base should be 1.8. That transistor is transisting. Let's look at H106. Y'all getting bored yet? Sounds like we're playing bingo here, huh? Alright, so 106. Could that be the strange, let's see, 110. There's 107. This has to be 106. So 106 is 7.7 on the collector. No. Yeah. Base is 3.6. No. Well, that's a little bit closer. And the emitter is 2.9. And it's 0. Another bad one there. So now we have another bad IF. I pretty much should just replace all of these stupid things, shouldn't I? Because if they're not bad now, they will be. Alright, so many of them were bad, I just went and replaced all of them. So, just for fun, let's just see how many of them are bad. I'll just fast forward through all this so you can see. Bad. Good one. That one's good. Several of these were good. A lot of them were bad. Bad. So, I don't know. You see, that one's good, and it's showing that there's a diode in there, which is very strange. So, that one's no good. Remember, these are pretty much all the same transistors for the most part. There's two different types. Bad. There's 4 bad ones. You see why I replaced them all now, right? Bad. This is what was showing in the tuner circuit as well when we checked the voltages. Bad. There's a good one. Bad. And that's a good one. So we had 4 good ones and 3, 6, 7 bad ones. So let's see if the radio works now. Okay, so as you saw how many bad transistors there were in there, I just went ahead and replaced them all because there was only 4 of them that were good. Now, I cleaned up the schematic a little bit to make it a little easier to read. And I'll pop this up on the screen so you can take a screen capture of it. But what I did was I went through and I wrote all of the substitutes I used for these, and I kind of marked what each of these stages are and what they do. But essentially, I did not have to replace the JFET, thankfully. But if I did, you could use an LSK 170A. These are expensive. These are anywhere from $5 to $10 a piece. That's still, you know, $5 to $10 to fix it. If it goes bad, well, I guess that's okay. And I put a note here because the bias on that LSK is a little bit different. Some of the characteristics are slightly different, so we might need to lower that. If we ended up having to replace this with an LSK 170, I would probably take this R104 over here for the base, and that's kind of set up your how this thing's going to work with bias and everything. And you might want to lower that from 100K to a 68 or 47K or something. I'm not sure. I just put a little asterisk next to that. I'm not sure that if this doesn't amplify properly, that would be probably where I would start, just to see, change this ratio a little bit here. But anyway, this H102, there is a transistor called an S9018. I have about half a dozen of them in stock. I actually had. And those actually are 600 megahertz RF oscillator transistors. And that's the closest thing I can find to a 2SC668 transistor. And I replaced that with this. Now, most of these other ones, like H103 through H109, those are all going to be KSC 1674s, and those are readily available. You can get those. Those are nice RF transistors. H110, 111, and 112, and 113, all of those, you can just replace those with plain old 2SC or KSC 1815s. Very, very common transistors. So that's what I have in there right now. And I've put the unit up on the, I took it off of the dim bulb so I don't have to listen to the buzzy isolation transformer. And I connected it to the electronic circuit breaker just in case something goes wrong. This will trip within I have it set for within one full cycle, it'll trip. And I have it turned on right now, and to my surprise, a bunch of transistors later, it's working. And if I turn up the volume, you can actually hear it's working. And look at the THD on this. It's like floating between 1.5–2%. It goes up and down. Of course, if you just touch the tuning knob, you know, it'll move. But so far, so good. I mean, it works well. So what I think I'm going to do, I don't even think this thing needs aligned, but let's connect it up to an antenna and see if we can get any stations and what they sound like. Okay, let's see what we got. I noticed the stereo light seems to be out. That's about normal for a low-end tuner.
Smarter, simpler way to order food for your workplace. With easy online ordering, search filters for budget, dietary needs, and more.
And I need to clean the rotor on the tuning gang. Again, not a really good reception today. And again, this is not a super high-end tuner. It doesn't have a really good pilot trap, and so from 19 kilohertz pilot trap and things like that. But it does have one RF stage, I guess. The AM is not anything to write home about. As you can see, it does use some of the transistors up here for your IF, but you can see there is your AM oscillator, and then it goes into the detector here. You have some up here is going to be your AM IF, and that's it. It just has a single IF. I mean, it's not really a very high-end AM tuner, so it's a city tuner. I mean, it's not really for DXing, but for what it is, it works pretty well, and it sounds good. So I think we're ready to move on and do the rest of this thing now. Now, a couple other quick notes before we move on. I did not change there's a couple of electrolytic capacitors. There's maybe 8 or 9 of them on there. I'll probably replace those because I'm sure those all have high ESR by now. The stereo indicator light is out. I'll need to change that. And just so you know, all of these, the only transistors were a drop-in replacement were the two SC1815s. If the 1674s and the S908s have different pin out, so you'll have to rotate the transistor in the socket. Let me see if I can zoom you in on one so you can see what I'm talking about. Let's see how close I can get to one of them. Let's just look down here at this one. And you see how that one is right there? So you can see the transistor, if you go straight across, is emitter, base, collector. And this isn't going to focus, but it's emitter, base, collector. So you can look over here and you can actually see where I have the emitter, and then the base is in the middle and the collector. So if you look at the diagram, it's kind of rotated one pin over. So instead of the flat facing forward like this, it's facing at an angle. You see that? So just make sure when you put this thing in that you don't get it in incorrectly, because the pin out is different. So my microphone was not on for the last maybe 2 clips. So where we are is the amp, as you saw, the tuner is working just fine. So what I did was I went through and I checked the capacitors. All of them were good. There was a couple of them that were just starting to get a little bit higher than normal ESR, but nothing to write home about. I replaced those. The rest of them are as good as new, and in some cases actually had some better specs than the ones I have to replace them with. So I'm leaving those alone, and I doubt that this tuner is going to get really much heavy use. Again, this is probably going to be my little receiver, so I'm probably not going to worry about a couple things like that. Now zooming in on these output transistors, and like I said, the amplifier works well. We heard it, and I don't really think, other than if maybe some of the transistors are noisy, but I didn't really see or hear any noise in the transistors themselves. These just have some, I wouldn't call it corrosion, it just appears as if the tin plating on the outside of the transistor cases has worn off. See that? Other than that, I think they're fine. These are kind of what gives this amplifier its sound, and I don't really want to replace them. I do have some vintage original spec TO66 transistors. They may not be the exact models of these, but they will be perfect replacements, but I don't want to put them in unless I have to. I kind of like leaving these original if I can, and leaving the sound original if I can. Now these blue capacitors here, some of the light blue caps are known to kind of go high ESR. Some of these other blue ones, however, hold up really well, and they almost never fail. So I'm going to go through and check them, but probably for the amplifier module, amplifier and power supply, I will replace the capacitors just because. Those are the ones that have, current and so forth going through them, more so than the little signal caps on the tuner board. So let me go over a few things here and I will be back. Okay, so here it is, my janky circuit board drying device. It's just a little space heater. It goes without saying, you stay with the heater when it's running because you don't want to risk, starting a fire. But anyway, this actually works really well. I don't have one of those little low temperature ovens to dry out the boards, but I found that this works really well. I've used it many, many times and never been disappointed. So this went in the ultrasonic cleaner, got all the gunk off it. It was pretty bad. These transistors actually shined up. They look pretty good, as you can see. So when this is all dry, I'll start recapping it and doing some other things. In the meantime, I was working on replacing this old filter capacitor. This just has a single filter cap for the whole big power supply for the unregulated part. And you can see I just clipped it off and left the terminals wired together for now so we know where everything goes. And what I decided to do was something a little bit different. I'm using one of these Adaptacaps. Now, if you haven't seen these, there is a company called Adaptacap, adaptacap.com, and I purchased these. I actually bought them. I reached out to them once and they sent me a few samples to try out, and I liked them so much that I bought a whole bunch of them. And then I don't know if you guys are into television restoration, but Bob Anderson over at B. Anderson TV, he uses these all the time. So anyway, what I did was I found this is a 3300 microfarad at 55 volts, and I have a really nice Nichicon 4700 at 63 volts, so this will be perfect. And I mounted it in the center of the Adaptacap, and then I got a couple of these little wire ferrules. You see these? They're feral like a cat. Yeah. So anyway, see these little wire ferrules, and you can buy containers of them. And what I did was, you can see the little flange on the one end. That's the part that normally goes down against the wire that you're crimping onto it. These are like, they're kind of like bootlace aglets that you put over the end of your shoelaces to keep them from fraying. Same thing with wire. But anyway, I just put them on backwards. I slid them down over the wires. You can see I just left a little bit sticking up the top of the capacitor leads, and then I soldered the whole thing together all the way around. And now we have a nice place to wrap our new wires around and solder them on there, and it'll look professional. And this will mount exactly in the same place as this. So it'll look really nice. So let's give this a little bit of time to dry, and then I'll get started on replacing some of these caps. And what I might do, most of these transistors will probably be good. Probably all of them will be good. But I'll kind of look up what transistors they are. Any ones that are known suspects for going bad, I'll replace them, and then we'll put it all back together. Well, as it turns out, I'm going to have to clear the bench here for a little bit to do a little bit of work. And I'll give you some bonus points if any of you can identify what this is. And yeah, you can read what's on there, but see if any of you X-ray folks out there to watch my channel know what this is. But anyway, we're going to just stop this video for right now for this receiver. And I'm going to get it off the bench. I'm going to do the work that I got to do. And then I normally don't work on things from work on this bench, but I think it would be a little easier for me considering what I have to do and some stuff. So I'm going to end this video right now and call it part 1. And then it'll just give me more time to do a part 2 video where we can go in a little more detail over the amplifier and cleaning the controls and some things like that. And if you all have any questions or comments or things you'd like to see in the part 2 video, you can post it down below, and maybe I can include that in there for you. So it might be actually work out for the best for all of us. So until then, I wish you all peace, joy, happiness, and good health in your lives. And I'll be back real soon with part 2, because as soon as I get this done, we'll get back to work with our Fun stuff, huh? Take care, everybody. Bye-bye.